Okay. Now I need to actually share my screen with y'all. Clicky. Window and that one. Okay. You guys able to see my screen now? No. Blast. Oh, now. Yeah. Okay. Sweet. Let's see. I need to make this. We'll do that. Okay. It's still not showing me. There it is. Okay. All right. Sorry about that big old delay. Um, Thanks for your patience. So, Physics 9 classwork. Remember to try to find the stuff that you need to work on. There's should be for you guys in between Google Calendar and under here somewhere there should be something that says view my work or something like that. That's where you can see what stuff you have not yet hit turn in on for this thing. And I don't remember if I've had this conversation. I think I've had it once with you just to make sure if you guys aren't seeing stuff show up in the calendar for this class or for any other class, you can go to your calendar right there and then time keeps ticking. Then over here, gears are grinding. We're getting there. Oh, over here, there's my calendars and other calendars. So if what we're doing, or if this class or some other class isn't showing up, you can usually go over here and find the calendars that are supposed to be available to you, and you can um, make sure that they're checked. And if they're not checked, they generally tend to disappear. If they're checked, they end up kind of showing up there. So just a quick note in case you're having issues seeing that stuff. Um, Click it, click it. All right. Um, Lesson plan. We'll just, oh, you know what? I already have that open up here. There we go. So just well, where's do I need to refresh this page? I threw a Thursday up there. There we go. I'm updating grades in both Google Classroom and in Skyward. I feel that if I update them in Google Classroom where you're getting them assigned, that's kind of a nice way for you to keep track just right in Google Classroom what you've turned in and what you haven't. So you should be able to see in Google Classroom through the view my work what stuff you've got. If you're just looking for like the different shadings of an assignment don't necessarily tell you if they've been turned in or not. Once I have them entered in Google Classroom, I then also enter them in Skyward. So if they're in one, they should be in both. All right. And I think the link that we use here for this live session, I think it's the same link every dang week. So I don't think we need to go looking for a new link. I think it's pretty much the same one every time. All right. Um, Today we'll go through and look at. We've done stuff with position versus time graphs, looking at uh, the slope of a position time graph tells us the velocity. And we've looked at y-intercepts for position time graphs, telling us the position when time is 0 seconds. We're going to today take a little bit of a look at velocity versus time graphs, just so we have another tool in the toolbox. And the velocity time graphs help us with things that'll be coming down the road, like forces, and in future physics work doing stuff with momentum and other things like that. So there are a variety of things where a velocity time graph ends up being helpful. Sorry, moving this background thing over a smidge bit that lets my family walk around. All right. So the Moving Man website, we used that earlier. Um, uh, we used it more looking at position versus time graphs. It also does a nice job with velocity versus time graphs and things like that. So I think it's something that we're used to, and it might be a nice way to start taking a look at velocity time graphs. Um, This takes a crazy long time to load. We'll get there. Maybe while it's doing that, I'm going to move over. Another thing that is used, because that does take a crazy long time for that to load. Another thing that's used sometimes is something called motion maps to kind of describe motion. And some of those are shown to us today in a later assignment. So this website here, Motion Map Maker, is kind of slick. If you look at the URL for most websites nowadays, they're all HTTPS with the S on the end being secure. And this website, if you go to load it and click on it yourself, you'll get like a warning, hey, not secure, that sort of a thing. I don't believe they have I don't believe they do the HTTPS, and their certificate, I think, is out of date. So I'm using it to demo to you guys. It isn't necessarily something that would be uh, awesome for you guys. It's not that the makers of the website are evildoer, ne'er do well sort of folks. It's that it makes it easier for others to hack the website. So that's the concern with those things. All right. So for this thing, so we have this nice, delightful position versus time graph. And I just typed data in here, making the position go up one step by one step. And so we notice our slope is constant. We've got just a nice straight line there, yeah. And if our slope is constant, we know our velocity is constant. And what this website does is it adds down below, hey, look, all these nice, delightful little dots. Oh, and little arrows on the dots. What a deal. Those dots with the arrows are called motion maps, or sometimes they'll drop the arrows and they'll just call them dot diagrams. And if the dots are nice and evenly spaced, then that tells us that the velocity is constant. The dots are kind of they're meant to be drawn or thought to be drawn like every second. So if you imagine a vehicle going down the road and somebody just drops like a little beanbag out the window every second, bloop, beanbag, bloop, beanbag, bloop, beanbag. The pattern that those beanbags make are the dots along the side here. And if their dots are nice, evenly spaced, then that means that the vehicle or the object is covering the same amount of space every second. So it's kind of nice and uniform like that. If I make it so that our position increases or behaves in some non-uniform way, um, mm, oops, I shouldn't make it that. Go. Oops, that's way too much. So I wonder if it'll let me just do that. So, bloop. So if we make it so that our slope is not constant, then that tells us that the velocity must be changing, right? Slope is the velocity, the slope of a position time graph. I need to clarify that. The slope of a position time graph is the velocity. And so if we go down here, those dots are now not evenly spaced because it covers more and more and more ground each second. Make a little bit of sense? Okay, a couple of head nods. So that's the idea with these motion maps or the dot diagrams. We'll see if this bugger is going now. Still, good Lord. Or I wonder if I need to be on it for it to load. I don't know on that one. Oftentimes, if something's going to take a while, I usually just run to another website and come back. I thought that would have worked on this one. So, how's the family? Good, good. Kids growing like weeds. we're we're doing all right. Everybody's kind of uh, we love each other, but we've also spent a lot of time together, right? So sometimes, yeah, yeah. Um, oh, ooh, uh, the cat was out and about. You've seen the dog. You haven't seen the cat. The cat hasn't come over here yet. My class of juniors and seniors saw the cat. Uh, Cat's name is Chicken. And we got her from somebody else who found out that they were allergic to cats, and they speak Bulgarian, I think, or they're from Bulgaria. Oh, here's the dog again. Here. Hello, I'm Chewy. Woof. Um, but apparently, in the language that my daughter's friend who had the cat initially, apparently, like in their language, saying "oh little chicken" is kind of like saying "oh cutie pie." So in their language, they called her "oh little chicken" every now and again as just like a term of endearment, and we thought that's now her name. So uh, there you go. Okay, um, there's the side chat. Hey, I feel closer to you all. Oh. Sorry, guys. Thanks for putting up with me. Okay, so we'll go here. We'll hit charts. And the stuff that we're going to be taking a look at today or focusing on more. I'll try to zoom in and see if that helps things at all. Ah, shoot, if I zoom in, it won't let me move my screen around because it's got a bunch of different adaptations to make this work because it's using like old Java or old Flash, I forget. So you can still kind of see that, yeah? Um, so Moving Man, and then on this website, I'm going to remove the. Whoa, that's unusual. I'm just trying to. Apparently, it doesn't want me to rearrange the size of that screen. Sorry, folks. Oh God, don't tell me I have to reload this whole blasted thing. Um, all right. Okay, so the moving man, I think it's let me do this before. Maybe that just wasn't working. There we go. So just getting rid of the block walls, the brick walls on the side, because now the guy can move beyond. So the a few things that I want to emphasize before we go any farther on this. Remember, positive and negative are used to describe directions. So on this website, they chose 0 to be in the middle, and they chose positive to be to the right towards the house. They chose negative to be to the left towards the tree. They we are in the way we understand physics, we believe that we can choose any frame we want. It's perfectly possible if we were starting this from scratch and we had access to the code, it's perfectly legitimate for us to say, hey, I want the tree to be 0 and I want to the right to be negative. That's perfectly legit. Physics still works. We just need to make some choice and choose that reference frame. The authors of the website chose the middle to be 0, chose to the right to be positive, chose to the left to be negative. So that's perfectly fine. Um, if we start off with a 0 position and we give ourselves some uh, velocity to the right, we'll see if it just lets me type in there 5. So I gave it a velocity of 5 meters per second to the right. Then we have them facing to the right. We have a velocity of positive 5. Positive means they're going to the right. There we go. And so the things that we'll take a look at are the position graph and the velocity graph. That's the stuff that we're going to try to focus on today. And one other thing I should say, sorry about that. I have a tendency, last thing, and then I say like 5 more things. One thing to say before we hit play on this, notice that this where the 0 is our time axes. And so this 0 is like a velocity of 0 here. And time is what's being marked as we go along here. So this is 2 seconds, 4 seconds, 6 seconds. On this graph, the 0 is our position. So starting at 0 meters, starting right there, and the time axis is running down here. Anything above this is a positive position. Anything below that is a negative position. For the velocity graph, this is 0 meters per second. Anything above it is a positive velocity. Anything below it is a negative velocity. So I'll give you a second to just think for a second on your own, commit to something, and if we're wrong, we're wrong. But research shows that if we think about what we expect first, and then we see the graph, and then we have to kind of reconcile things. There's a lot of research that shows that thinking about it first really helps solidify what is actually happening. So we have them starting at 0. We have a velocity of 5. Think about what the position graph will look like. Think about what the velocity graph will look like. And no offense, we'll be wrong on them here and there, right? So no big deal. Okay, you have a thought? which way the graphs will, what they'll look like. A couple of head nods, a couple of, I think I'm watching a different video off on the sides. That's all right. We hit play. So we see that position time graph having that constant slope, like what we've seen before. We see that velocity graph just being a horizontal line, which might be surprising um, because we're used to these angled lines for our position time graph. So now remember, the slope of this graph tells us our velocity, right? And if our slope is constant, that tells us the velocity is constant. I'm going to stop it there. So if our velocity is constant, this graph down here, the vertical part tells us how fast we're going. So the vertical part, where the dot is being traced out on the line, vertically, that has to kind of stay at about the same spot, right? I mean, if it's always going 5, it's going 5 meters per second, 5 meters per second, 5 meters per second, 5 meters. The height of this thing, where this is up and down vertically, should be constant. So here. So where this is vertically should stay the same if the velocity is constant. Yeah? All right. Now let's see. We'll do a reset. Reset all. And instead of starting off at 0, we'll start the moving man at 5 meters. And we'll give the velocity, we'll stick with, well, here, I'm going to make the velocity 6 just because now I pay a little bit more attention. There's a 6 on the graph, so we'll see it. So we're starting the person off at 5 meters and a velocity of 6 meters per second. And if we hit play, think for a second, what should our graph look like for our position time graphs? Think for a second, what should the velocity graph look like? We have a position of +5. We have a velocity of +6. Okay. So hopefully after seeing that, that kind of makes sense and agrees with what we know. Our velocity is +5, so we have this nice angled slope, positive constant slope. We start up at 5 meters because that was the position at which we started, right? So if we started at 5 meters, if that's the initial location, that's where our position time graph should start, constant slope. We hit the brick wall, so our position stayed constant there. If we're going to the right, if we're going with a positive velocity, that's just positive velocity. There we go. We hit the brick wall and suddenly shoot down to a velocity of 0. Our position stayed +10. Our velocity changed to 0. Okay, dokie. Then if we change our position back to 0, and I need to reset. My apologies. Yes. If we change our position to 0 and we make our velocity go left, how are we going to make the velocity go left? What do we need to make different about our velocity? Think about that for a second. Okay. So going to the right, we were saying like +5, +6. If we want it to go to the left, we need to make it a negative velocity. So I'm just going to hit -6. And now we can think about what our position graph will look like. We can think about what our velocity graph will look like, make a little bit of a pre-thought prediction, see what we get. So there we see the slope is constant. It's just not constantly this, it's constantly that. Yeah. So our position time graph, we have a negative slope. That means we have a negative velocity. And the negative just tells us the direction we're going. We're going left. And our velocity, oops, hit pause. And our velocity is always negative, just meaning we're going to the left. So constant position or constant velocity, this graph is just always that straight horizontal line. It's just like, how fast are you going? -6, still going -6, still going -6, still going -6 meters per second. So we can see things set that way. If we start at a positive position, we can start at 8, and we can still have this negative velocity. We can still have a velocity of -6. So the sign for our velocity only tells us the direction we're going. It doesn't tell us where we are. So think about again here. We're starting off with a position of 8 meters, and our velocity is going to be -6. Our position is +8. Our velocity is -6. So think about that for a second while you're going. Little prediction in your mind. Okay. And so there we again see our velocity is negative. The slope of our position time graph is negative. Our velocity is always -6. So the velocity graph is -6 meters per second, -6 meters per second. The velocity graph is just always -6. So we can see those things run as we go. The sign for the velocity tells us direction. It doesn't tell you where you are, right? If your folks are wondering where you are at some point, and you tell them, relax, I have a, yeah, I mean, obviously you're not going to say this, right? But relax, I have a velocity of +3, right? Telling them how fast you're going tells them nothing at all about where you are, right? If you're driving in the car, your folks are, somebody's giving you a ride home, and your parents say, "Where are you?" I'm going 20 miles an hour. That's great. That doesn't tell your folks where you are. It tells them how fast you're going, right? I mean, if you're running, that's impressive. Nice job. But if you're riding in a car, so what? So the sign for the velocity tells you the direction, doesn't tell you where you are. Let's see. What was the other thing I wanted to take a look at here? Uh, um, so there's one more thing with this, and then I want to show you how to do, or I want to discuss how to do the physics classroom stuff, because we're going to have a physics classroom assignment here. Um, or should we do that today? Maybe we won't do that. You know what? I think that might be enough for us on the assignment that we need to do today. I think anything more I do here might be useful for tomorrow, but I don't think we need it today. So I'm going to leave it at that for that part. The physics classroom assignment that you guys have today. Um, so physics classroom here and here, these two assignments, most of you registered for physics classroom early on. And today we're gonna finally go through and use it. Physics classroom gives you a variety of questions, and then it kind of cycles through questions, and you're done when you get them all right. And it throws different variations on them. Now I'm not giving you like 50 practice problems. One of these is 4 questions, one of them is 6, something like that. So like 10 questions. And if you get one wrong, it recycles and gives you a slightly different version of a similar question to try to get. But when you open these things up, when you go to these assignments, I added a YouTube link. So like a mini tutorial. If what we've done in these 25 minutes hasn't helped, then this little YouTube video should help a little bit and help you get going. Um, but to get the physics classroom stuff working, we need to kind of shift things a little bit. I don't know if this will work. I'm going to try to share a different screen um, on here. Let's see. I had to make a new email account, and everything's a little bit of a mess for me to log in as a student to physics classroom. Um, so give me a sec here. Physics classroom. There we go. We'll see if that goes. Ah, dang, always getting that stuff going. Okay, thanks for your patience there. So I'm going to share a different screen. Stop presenting, and now I'll share a different window. That one. Share. I'm the sort of person that talks to myself, and I talk to myself in front of other people. I'm okay with that. Okay, so physics classroom stuff. So when you go here, it's not as intuitive as one would hope. You registered for this early on. You should be able to go to my account to sign in. And now in my account, I can click on tasks, and this it loads an ad and it always goes up and down. I find that really frustrating. Um, but then you go to tasks and courses, and now it shows the assignments that are available to do today. Um, so we're in the area of one-dimensional kinematics. Kinematics is the $2 word for motion, right? Kinematics just means things are moving. Um, so this teacher message is some stuff that I just kind of typed out to hope and make sure things were good. If you are seeing this in physics classroom, not Google Classroom, but physics classroom, if you're seeing this in physics classroom, you're logged in. Um, so to go through and do this, I hit start this task. Excuse me. And that'll just start me going through this assignment. I can click on this view requirements. If I click on view requirements and it says, hey, the apprentice level, is that required? Yeah, 6 points. Um, there's no penalty for being submitted late. And I should maybe have emphasized this more often, but the timelines, the dates, the due dates are always just to try to keep us on schedule here and to try to keep things from piling up for you. If you turn things in a few hours late or the following day, you're not gonna see me at your doorstep holding a baseball bat saying, "What's up, kid? Get this crap in." I mean, that's silly, right? There's a bunch of stuff going on. So the due dates are just to try to keep us on schedule. And if you go to the requirements for this next task, view requirements, apprentice level is required. Yes, master level. So they did like apprentice, master, wizard. And I'm just asking you to do the apprentice level. I'm letting you take a look at, if you want to take a look at the master level stuff, but you know, so to go through and do these things, then you hit start this task, and they pop up like this, and then it's launch concept builder. Clicky. And then at this stage, this is the big spot. So some people will go, and instead of going through the my account part, some people will go right to the concept builders. But here's the deal. I couldn't make one to show you these steps using my normal school account, but on this thing, um, right there. So what you should see here is your school email account. If you see guest here, then it's not keeping track of what you do. If you see your school email account here, then it's keeping track of the work you're doing, and it will record your score, and I can check that score and put it in. And your score will basically be, hey, you did it, full credit, or hey, you didn't finish, not credit. So we just need to keep on trying as we go. And then you can either hit start here, or you can click this thingy and full screen, and you can kind of work off of that. And then you hit start, begin apprentice level. And then it shows things like this. On this one, you toggle through and we try to find things that are right. And if we get it wrong, it says, oops, you got it wrong. And if you get it right, it says, hey, nice job, guy, way to go. So that's the idea there. That's everything for today, I believe. Y'all with me there? Okay. So I think here I've taken up a half hour of your time here. Thanks for hanging out. I think if you switch gears from this to doing there are two tasks in this assignment. Um, sorry, going back and forth. There are two tasks in this assignment for today. And I think if you go right to that, I think we can get those done within a half hour, and we're done with class in a full hour, including this conversation and that. If you have any questions, let me know. Peace out. Hit subscribe, jam the likes, uh, follow. If you have any questions, you can stick around and ask them. If you're just done, hey, same to you, kid. If you're just done, you can just be done. I'm going to babbling here. Just hey, you too, kid. Thanks for saying hey. Woo! Yes, ma'am. Yep. No, no, you get 100%. Yeah. So it's just as it might some people might get some questions right first time through. Some people might take 3 tries or 5 tries or 30 tries, but when you're done, you get 100% credit. Yep. Have a good one.